Question 9. Question 9 is a deceptively difficult problem. I don't really like question 9 because to really solve it concretely, you have to do some pretty challenging stuff. But I bet if this were a test question, a lot of people would end up getting it right, that we're not able to do that really challenging method. Let me show you what I mean. When you stare at this graph, we know that this point is at 2, 1. In other words, its x-coordinate is equal to 2. And we know that this point is 10, 3. In other words, its x-coordinate is equal to 10. We can't guarantee that this graph is drawn to scale, but if it were drawn to scale, and from the origin where x is equal to 0 to here is 2 units, then another 2 units looks like it would take us right about to the vertex. It looks like the vertex is right around 4. Let's see if that scale holds up. If I go about that distance again, I'd be at 6. About that distance again, I'd be at 8. And about that distance again, I get to this point 10. It sure looks like this point is at 4. Maybe it's not at 4. Maybe it's at 3.9 or 4.1 or something. I don't know for sure that this is 4. But if I'm just guessing my way through this test, I might guess that it's equal to 4. And it turns out it is equal to 4. And if you're working under that assumption that this point is equal to 4, well then all you have to do is calculate the slope of this line. To get from this point that has an x-coordinate of 4 and a y-coordinate of 0, to this point that has an x-coordinate of 10 and a y-coordinate of 3, it looks like I go up 3 units and I go to the right 6 units. The rise is 3 and the run is 6. The slope is equal to 1/2. The answer to this question, the value of a, is going to end up just being equal to 1/2. If you think back to function transformation, stuff that we went over in the previous video for question 8, you might look at this and think about a as a vertical transformation and b as a horizontal transformation, both transforming the original graph y equals the absolute value of x, which looks something like this, because the absolute value of 2 is just equal to 2, and the absolute value of 4 is equal to 4, and the absolute value of 6 is equal to 6, and the absolute value of -2 is equal to 2, and -4 is equal to 4, and so on. If you know how to interpret a and b in terms of function transformations, and you think that the vertex ends up over here with an x value of 4, then you know that b must be equal to 4. You know that f of x must be equal to something times the absolute value of x minus 4. So think about applying this transformation. I'm going to add 4 to all the old x values. This point is going to go here. This point that started out at 2, 2. I'm going to add 4 to the x values, so it'll go to 6, 2. This point that started out at 4, 4. If I add 4 to the x values, is going to go to 8, 4. What I'm saying is just applying this transformation, this point maybe that starts out at -2, 2, if I add 4 to its x-coordinate, it ends up at +2, 2, so right about there. And if I start to connect all the dots, I get this dotted graph in green. This is y equals the absolute value of x minus 4. It's not what I want, but it's very similar to what I want. It's shifted correctly. Now all I have to do is kind of squish it down, compress it towards the x-axis here. How much should I compress it down? Well, pick whatever point you want. I got this point right here that's at 2, 2, and I want that point to end up down here at 2, 1. I want the y-coordinate to go from 2 to 1. What do I got to multiply 2 by if I want to change it into 1? Sure sounds like I should multiply it by 1/2. The graph in black is going to end up being y equals 1/2 times the absolute value of x minus 4. Not sure if that's right. You can confirm with this point. If I change all the x's into 10s and y's into 3s, do I get a true statement? Is 3 equal to 1/2 times the absolute value of 10 minus 4? It sure is, because 10 minus 4 is 6, and the absolute value of 6 is just 6, and 1/2 times 6 is equal to 3. That checks out. This is my equation. A is 1/2. Comment: this all relies upon me guessing that this point is at 4. What if this point is not at 4? What if it's at 3.9? If you really want to do this problem correctly, you can't assume that this is 4, although I bet a bunch of people did and ended up getting it right because it turns out it is 4. But if you don't know that this is 4, what could you do? Because I've destroyed this graph up here, let me try to redraw the graph. I start out with a point at 2, 1 and another point at 10, 3. And then I got the vertex somewhere in between the two. It looks like it's 4, but who knows if it's really 4. Can't really trust a graph. Rather than just assume this is 4, what we could do is introduce a new variable, an unknown. I don't know, the letter x maybe. And let this distance right here represent x. If this distance is x, then this point is 2 plus x. And since this point and this point start out being separated by a horizontal distance of 8, right? From 2 to 10, you have to travel 8 units. and I've already used up x of them to get from this point to the vertex, I'd have the remaining 8 minus x over on this side. If you're comfortable enough with function transformations to know that this b is not going to affect the slope of your absolute value lines, it's just going to shift your graph to the right by b units, and you know that the slope of this line is 1 and the slope of this line is -1, then maybe you can recognize that when you multiply all the y values by a, the graph that you end up with is going to have a slope of a on this side and -a on this side. What I'm saying is that the slope over here is a, the original 1 times the transformation of a, and the slope over on this side is -a, the original -1 times the transformation of a. Look what happens when I write the slope in terms of rise and run, right? From this point to this point, I know that the y-coordinate here is 0 and the y-coordinate here is 3. So the rise is 3. And the run, the distance I went to the right, is this 10 minus this 2 plus x. In other words, this 8 minus x. Maybe I'll copy it for the sake of legibility. A is I don't know if that's even a word. A is equal to 3 divided by 8 minus x. I can do that same thing over here. I know the slope is -a. The slope is rise over run. This graph goes up from this point to this point by -1. The height here is +1. The height here is 0. I'm going down 1 unit. In other words, I'm going up by -1 units. How much do I go over? I go to the right x units. I have these two equations with two unknowns, the letter a and the letter x. A really useful skill would be able to solve when you have two equations and two unknowns. I want to know what a is equal to, so I want to get rid of the x's. So what I'm going to do is I'm going to solve one of my equations for x and then plug that into the other equation. This equation seems a little bit easier to solve for x. Maybe I'd multiply the x up to the top of this equation. So I got -ax equals -1, and then divide both sides by -a to get x is equal to 1 over a. Then I can come over to this equation, and everywhere I see the letter x, I can change it into 1 over a. I got a is equal to 3 divided by 8 minus 1 over a. Solve this equation for a, and you're done with the problem. Unfortunately, solving that equation for a is kind of ugly because I got fractions inside fractions. But what I could do is multiply both sides of the equation by the denominator over here. It would cancel out on the right side and it would show up on the top of the left side. So I'd have a times 8 minus 1 over a on the left. And on the right, I would just have a 3. Now I can get rid of the parentheses by taking the a and distributing through. I got 8a minus a times 1 over a, in other words 1, is equal to 3. Add 1 to both sides, you got 8a equals 4. Divide both sides by 8. You got a is equal to 4 over 8, in other words, 1/2. Even if you didn't know that this was 4, you could still figure out the value of a. You just have to be a little bit more clever in how you did your analysis. One more thing I want to talk about before I end this video. It's the absolute value function. A lot of people think about this as like the distance from 0 or the function that makes everything positive or something like that. But here's a better way to think about it. The absolute value of x is equal to one of two different things. It's either equal to x or it's equal to -x. It's equal to x if the value of x, the input, is greater than or equal to 0, and it's equal to -x if the value of x is less than 0. And you're like, no. The absolute value of x is never equal to -x. You're stupid. I know a lot about the absolute value, and it's never negative. Right. But if x itself is negative, if x equals -2, for example, the absolute value of -2 is equal to the negative of -2, right? If x is -2, I follow this second rule. I take the negative of -2 to get +2. So I'm not saying the absolute value itself ends up being negative. I'm just saying that if the thing you're taking the absolute value of is negative, then you have to change the sign of the thing inside those absolute value symbols if you want to get rid of those absolute value symbols. Right? If you think about this as the definition of the absolute value, it allows you to get rid of the absolute value symbols, which is really useful when you're trying to solve things algebraically with an absolute value symbol in there. Why would you ever be doing that? Because another way to attack this problem is recognize because it goes through the point 2, 1, when x equals 2, y equals 1. So I can copy exactly what I see here, changing all the x's into 2's and all the y's into 1's, and I get 1 is equal to a times the absolute value of 2 minus b. This equation just comes from the fact that it goes through the point 2, 1. I'm also told it goes through the point 10, 3. Therefore, 3 must be equal to a times the absolute value of 10 minus b. I don't know what b is equal to, but based on my knowledge of function transformations, I do know that b is whatever this number is right here. It looks like it's 4, but maybe it's not 4. Maybe it's 3.9 or something, or 4.1. It's hard to tell. It's certainly bigger than 2 and less than 10. It looks like it's 4, but I don't really know what it is. If we're not going to assume that it's equal to 4, that's okay. Up here, we have 2 equations and 2 unknowns, kind of similar to down here when we had 2 equations and 2 unknowns. It would be awesome if you recognize that anytime you have 2 equations and 2 unknowns, unless those equations are redundant, which they won't be for your purposes, I don't mean to confuse you. If you have 2 equations and 2 unknowns for your purposes, you'll be able to solve for those unknowns. We're going to do the same method up here that we did down here. Down here, we wanted to get rid of the x's so that we could figure out what a is equal to. Up here, we want to get rid of the b's so we can figure out what a is equal to. How are we going to get rid of the b's? We got to solve one of these equations for b and plug it into the other equation, kind of like we did down here for x. The problem is the b is hidden inside this absolute value symbol. And for a lot of people, that just completely destroys any chances they have to solve things algebraically. But that's not the case for you, because you understand that if you want to get rid of absolute value symbols, sometimes you can just get rid of them not doing a damn thing, and sometimes you can get rid of them if you just multiply everything inside the absolute value symbols by a negative. If the thing inside the absolute values are positive, just drop them. It's not doing anything. If the thing inside the absolute value symbols are negative, then you have to multiply by a negative when you drop those absolute value symbols. So my question to you is 2 minus b negative or positive? Is 10 minus b negative or positive? Because if you can figure that out, if you know, you don't need to know what value this is, you just need to know is it negative or positive. If you know whether it's negative or positive, you know how to get rid of the absolute value symbols. We'll be able to solve these 2 equations and 2 unknowns. So which is it? I don't know. Yeah, you do, because b represents the new vertex here. The number, the x coordinate of this point is b. Think back to function transformations from the previous video. The a doesn't do a damn thing to the x values. It's the b that changes the x values. All your horizontal transformations come from this. The point that started out with an x coordinate of 0 ended up with an x coordinate of something. It looks like it's about 4. So b is something that's about 4. B is definitely bigger than 2 and definitely less than 10. If I take 2 and I subtract something that's definitely bigger than 2, I end up with a negative number. What's inside the absolute value symbols here is definitely negative. And what's inside the absolute value symbols here is definitely positive, because b is some number that's less than 10. If what's inside the absolute value symbols is positive, then the absolute value symbols aren't doing a damn thing. Just get rid of them. 3 is equal to a times 10 minus b. But if what's inside the absolute value symbols is negative, you can't just get rid of them. You have to change the sign of the thing inside the absolute value symbols. How do you change the sign of 2 minus b? A handy little algebraic trick is recognizing that reversing the order of subtraction is the exact same as multiplying by -1. Don't follow that? If I have, 7 minus 5, I get 2. But if I switch the order of subtraction, if I make it 5 minus 7, then I almost get 2, but not quite 2. Now it's -2. Switching the order of subtraction is the exact same as multiplying by -1. If you really want to see it more algebraically, -1 times 7 minus 5, I could take the -1 and distribute it through the parentheses, and I get -7 plus 5, but -7 plus 5 is the same as 5 plus -7, because addition is commutative, and 5 plus -7 is the same as 5 minus 7. But you don't have to go through all these steps every time. Just remember that when you reverse the order of subtraction, you're really just multiplying by -1. Then if I want to get rid of these absolute value symbols, I got to multiply what's on the inside by -1, because the absolute value of a negative number is the negative of the thing you're taking the absolute value of. So I change 2 minus b to b minus 2, and I can drop the absolute value symbols. Now I got 2 equations and 2 unknowns, and I don't have those stupid absolute value symbols, so now it's easy to figure out what a is, or at least relatively easy. Solve one of these equations for b, plug it in for b in the other equation, and figure out a. I'm a little low on room, but I bet I could squeeze this in somewhere. I don't know, maybe in a different color down here. Sure. Let's take this first equation and solve it for b. Lots of ways you can do that. One way is divide both sides by a. So I got 1 over a is equal to b minus 2. And then add 2 to both sides of the equation. And I got b is 1 over a plus 2. And then take that and plug it into your other equation. My other equation is 3 is equal to a times 10 minus b. But I'm not going to write b. Instead, I'm going to replace this b with what b is equal to, 1 over a plus 2. Side note, make sure you put these parentheses in here, because without these parentheses, you won't be subtracting the entire b thing. You'd just be subtracting the first term, the 1 over a. Anyways, this equation might look really ugly, but it's really not that bad because it only has one unknown, the letter a. So let's get that a by itself. How are you going to do that? Well, maybe if we start chipping away at these parentheses. Let's get rid of these inside parentheses by taking this negative and distributing it through. I get 3 equals a times 10 minus 1 over a minus 2. Might as well clean things up. 10 and negative 2 is just 8. So I got 3 is equal to a times 8 minus 1 over a. Or if I take the a and distribute it through, I get 3 is equal to 8a minus a times 1 over a, which is just 1. Think a times 1 over a is the same as a over 1 times 1 over a, which is the same as just 1. Anyway, solving this for a, I add 1 to both sides. I get 4 is equal to 8a. Divide both sides by 8, and I get a is equal to 4/8, in other words, 1/2. The answer to the question, whether you guess that b is equal to 4, or you solve for a using the slope, or you solve for a kind of taking the advantage of the fact that we're given these 2 points, regardless, we figure out that a is equal to 1/2. It's worth pointing out that once you know that a is equal to 1/2, it's really easy to figure out what b is equal to, because you'll already have an equation that tells you what b is equal to in terms of a. So b is just equal to 1 over a, the reciprocal of a. The reciprocal of 1/2 is 2 over 1, in other words 2, plus 2 more. B is equal to 4. Yeah, that's what it looked like in the picture originally. It turned out that was right. But this answer of a and this answer of a are not dependent upon guessing that this value is equal to 4. I know I said one last thing like 10 times, but maybe one last thing. If you do one of these methods and you kind of think you're right, but you're not entirely sure and it's not multiple choice and you really want to make sure you're sure, what you could do is pull out your calculator here and graph this function when a is equal to 1/2 and when b is equal to 4, the two values that I'm pretty sure are right at this point, and make sure it looks like the graph that we see here. Let's see if it works. I got 1/2, which you can put in as 0.5 or 1 divided by 2, it doesn't matter, times, which you don't even have to write, or you can put in a time symbol. The absolute value, that's kind of hidden. It's under the math menu. And then if you go over to numbers, it's the first thing listed in this kind of sub menu, ABS. You can hit enter. If during the pressure of the test, you forget where that thing's hidden, but you really want to find it, another option is to go into the catalog. So catalog is above the number 0, and that kind of contains all of the different functions that your calculator has. So if you hit second and then 0, it'll show you all the different functions your calculator has in more or less alphabetical order. And conveniently, absolute value is really early alphabetically. It's the first thing that shows up in here. So that one's way up at the top. But if you're looking for something else other than absolute value and you couldn't find it, and you didn't know the shortcut menu to get there, you could use the catalog. Like, I don't know, maybe you're trying to find, the median or something. You could just scroll down in your list all the way until you got to the M's for median. Or since alpha lock is on up here, you could just click on the key that has an M on top of it. Here it is right here. Here's the M up in green. And that'll jump me down to all the M's. And now I can kind of look through the M's until I find something that looks like median. If I didn't remember where to find median under the stat menu, I could just find it under the catalog. Similarly, if I didn't remember that absolute value was under the math menu and then over in number here, what I could do instead is find it under the catalog here, second and then 0. Anyways, back into y equals here, I have 1 divided by 2 times. Since I remember where absolute value is, I'll just get it under the math menu. Absolute value, hit enter. And then instead of x minus b, since b is 4, I'm going to put in x minus 4. You don't even have to close your parentheses. It'll just assume you have closed parentheses at the end, and you can hit graph. Take a look at this graph, and you're like, yeah, that looks a lot like what's pictured in black. I'm feeling pretty good. Or maybe you're like, I'm still not sure I'm right. Well, what I could do is hit the trace key, and then I want to confirm when x equals 2, y equals 1. So I just hit 2. It puts in x equals 2. I hit enter. It tells me y equals 1. Cool. When x equals 10, will y be equal to 3? Well, I'm still in the trace menu, so I can just type in 10, Hit enter. It tells me y equals 3. I'm feeling really good about these answers. I've confirmed that a is equal to 1/2 and that b, even though it's not asked, is equal to 4.